Hello everyone, this is week 5, Unit 5 quiz. The topic this week is hopefully familiar to most of you. I'm guessing you would remember most of this stuff from high school algebra classes. So let's start with the first question. So this is a rational equation, and we're trying to solve this for x. Since there are denominators here, our goal is to eliminate those denominators. So for example, here I have a 10 at the bottom, so if I multiply this by 10 I can eliminate that denominator, but I would have to do that across the board for all the terms within the equation. So if I multiply by 10, this denominator 5 would also be eliminated, but the 20 would not. So then multiplying by 10 is not a good idea. So why not multiply by 20 then? So, because if I multiply by 20, because 20 is a multiple of 10 and 5 and 20, so multiplying everything by 20 will eliminate all of the denominators. So if I multiply by 20, what happens is 20x divided by 10, and then plus 20 divided by 5, because it would be 20 times 1 divided by 5, and this would be 20 times 3 equals 20 times 3 divided by 20. So it might actually be better to just write these like 20 here, 20 there. These are multiplications, and 20 there. So when I do that, this 10 goes into the 20 two times, so the very first term would be just 2x, because the 10 goes into 20 twice, so there's no more denominator, it's just 2x. And here same thing, 20 times, this is 20 over 5, which is 4, or you can just say 5 goes into 24 times, so it's plus 4, and then equals 20 times 3 over 20. These two 20s will just cross out, which will leave me with just 3. So now I have this equation, 2x plus 4 equals 3. So if I now I'm trying to get to x. If I subtract 4 from both sides, then the positive 4 and negative 4 here would be eliminated. So I have just 2x on this side, and then 3 minus 4 would be just negative 1. So I have 2x equals negative 1. And then as a last step, I just divide both sides by 2, which would give me x equals negative 1 over 2. So that would be your answer, x equals negative 1 over 2. So let's look at question 2. So in question 2, so the equation given is 2x minus 9y equals 18, and the question is solve for y. So that means I need to make this look like y equals something something. So y should be by itself on the left hand side. So then my starting point here is first get rid of this 2x. So what I can do is just subtract 2x from both sides. So subtract 2x from both sides. So if I subtract x from both sides, then 2x minus 2x, these two will cancel out. So I will have just negative 9y, so this thing comes down, equals 18 and negative 2x. I can't really subtract them. This is not 16x, because this has an x, this is just a constant. They're not like terms, so I would have to write negative 2x plus 18. So I'm closer to my goal, writing this as y equals everything else on this side. So all I have to do is now get rid of this negative 9. So some of you might be thinking we can just add to cancel this, but that will be wrong because this is not negative 9 plus y, this is negative 9 times y. So the opposite operation would be divide by 9. So if I divide everything by 9, then I get y equals, so divide by negative 9, I'm sorry, because there's a negative 9. So if I divide everything by negative 9, it will cancel out this negative 9, and then here you would have negative 2x divided by negative 9, and then plus 18 divided by negative 9. So here negative 2x divided by negative 9, that would just be, the negatives will cancel out, so it's just 2x divided by 9. And then plus 18 divided by negative 9 is just negative 2. Or you can just say y equals 2x divided by 9 minus 2. So if I have to write this here as an equation, insert equation. So y equals fraction 2 over 9x minus 2. So that would be the correct answer. Okay, so number 3, we're given a graph, and from this graph we're being asked to find the x-intercept, y-intercept, slope, and the equation of this line as y equals. So let me make this bigger because I can't quite see the graph. So the first thing is x-intercept, right? So remember, x-intercept is the point on the x-axis where the graph intersects or cuts through. Just make it a little bit bigger. So as you can see for this graph, this is the exact point where the graph cuts through x-axis, and that point is, this is the origin, which is 0. So if you're going left, that's the negative side, and it's just 1 unit left. So the x-intercept is negative 1. Y-intercept, in the same manner, is the point on the y-axis where the graph goes through, and that point is right here, which is 2 units below 0. So y-intercept is negative 2. So again, x-intercept is negative 1, y-intercept is negative 2. And the slope, is, you can determine slope by rise over run. So let's just, you can pick any 2 points on the graph. So let me just pick the 2 intercept points. So from this point, from x-intercept to y-intercept, my rise is, so I'm actually falling, so that's negative. So rise, if you go up, that's positive, down is negative, left is negative, right is positive. So from this point, how do I get to this point? I would have to go down 2 units, so that's negative 2. So rise is negative 2. And then run, that's 1 unit to the right, so that's a positive change. So 1 unit to the right, so that's positive 1. So the slope is negative 2 divided by positive 1, which makes negative 2. So the slope, x-intercept was negative 1, y-intercept was negative 2, slope is negative 2, and remember the slope-intercept form was y equals mx plus b. So then this would be y equals m is the slope, which is negative 2x, plus b is the y-intercept, which is negative 2 again. So this can be written as y equals negative 2x minus 2. That would be the question for the last, the answer for the last part. So number 4 here is they're giving us an equation and the question is find the slope of the graph of this equation. So since the equation is given, if I can put this equation in the slope-intercept form, which is this, y equals mx plus b, then I can easily identify the slope, which would be the coefficient of x. So m here. So my original equation is 4x minus y equals -5. So I'm trying to isolate y. So the first thing I need to do is get rid of this 4x. So if I just subtract 4x from both sides, subtract 4x, then I would get, so now I can cancel these out. So what I have is basically -y equals 4x is cancelled, -y is left on the left hand side, and then this is -5 minus 4x. Remember again, these two are not like terms, so I cannot combine them. So what I would do is write the -4x and then -5. Okay, so it's -4x minus 5. So is it in the slope-intercept form? Not quite, because we don't need this negative here, so I need to get rid of it. So if I just multiply this whole equation by -1, then that's going to turn this into a positive. So that means every single term here, the y, the x, and this constant 5, they're all going to be multiplied by negative, just so I can have y equals, so -1 times -y would be just positive y. So that would be, and then -1 times -4x is positive 4x. So everything, since everything is negative here, they're all going to turn positive. So this -5 would be plus 5. So the equation now in slope-intercept form is y equals 4x plus 5. So now that it looks like y equals mx plus b, I know that m is the slope, which is positive 4. So the answer would be here 4. Okay, so question number 5, we're given the graph of an equation, a function. So the question is, when f of x equals 3, what is x? So basically the input is unknown, but the output is known. And remember, input is always x, output is always y. So in this graph, we don't know what x is, but we know y is equal to 3. So find 3 on the y-axis, which is, let me make this bigger. So 3 on y-axis is right here, right? 1, 2, 3, 4. So this is 3. So imagine a horizontal line going through y equals 3, right there. So this line cuts through the graph right at this point. And what is the corresponding x value of this point? Right down here, 2. So that means when x equals 2, y equals 3. So that means f of 2 equals 3, so that means x equals 2. So that's how we solve these kinds of questions. Y is known, so find y, and then imagine a horizontal line wherever it cuts through the graph. Find the corresponding x value, and that's your input. So number 6, we're given an equation, and the question is, does this equation constitute a function with independent variable x? So for this to be a function, for every value of input, for every value of x, there needs to be exactly one corresponding y. And this is actually an equation of a circle. So you can tell that this is not a function because, for example, if you assume whatever the value of x is, let's say x is 0, then y squared would be 9, which means y can take on two values, which is 3 and -3. So since y does not have a single value, it has two different values for the value of x, this is not a function, so you would say no. And a counterexample we've already given for x equals 0.